or what's called in the programming's perspective. So this is known as the variable definition. So we have defined a variable, or we have defined a specified space inside the computer's memory when this program will run. So this program isn't actually running, we are building this program, but when this program is executing, it's going to go back to the memory through the compiler, and it's going to tell the machine, or it's going to tell the memory, that I need 4 bytes of space so that I can store an integer number or an integer value or a whole number. Whole numbers are necessarily integer numbers. They can be negative, they can also be positive. So I want to store a whole number, and this will be an integer number. It might be negative or it might be positive. So I need 4 bytes of space from your memory. So that's going to this integer, this data type, is going to tell to the memory that I need a certain amount of space, which in this case is 4 bytes, and that will have a name of num. Then again, we have different data types. Now the data types give you a range, like from 0 to 100, 0 to 1000. These are all range. Like for our example of the mineral water bottle, you can store up to 1 liter of water, which is, I guess, it's like 1000 milliliter. Yeah. So from 0 milliliter, you can store up to 1000 milliliter of water inside that container or inside that bottle. But you can't exceed that, or you can't exceed above it, or you can't exceed below it. It doesn't make sense if you exceed below it. Like you can't store negative amount of water inside a container. Obviously that doesn't make sense in real life sense, but it does have some perspective when we try to talk in terms of programming's case. So inside that similar container that we have obtained from the RAM, or inside that space that we have obtained from our memory, we can store negative integers or negative whole numbers like minus 99. We can also store positive integers like positive or plus 99. The difference is that we don't actually mention positive or plus 99, we just say 99, and we can implicitly assume that that's a positive number. But when we try to imply negative numbers, we always say negative or minus 99. So let's also head over to some other data types. There's another data type called Char, or character, or Char, whatever you say. So this is similar to our previous example, but the character data type, or this Char, this is the short form of the full abbreviation. But you see, if I write the entire English word, our IDE doesn't actually understand. So programming has its own grammar. So when we try to talk in terms of programming, when we try to communicate to our compiler, we need to use the syntax or the grammar of the C programming language. So in this context also, or in this variable declaration, I have named a container, or I have assigned a storage space with a name called ch, and that is going to take 1 byte of space from the memory. And how do I know that? From this data type. So this data type is actually a certain type of range. It's taking it's going to store, you need an amount of space to store water. So a 1 liter bottle mineral water bottle can actually store up to 1 liter of water. So this character data type, or this character variable, which is known as ch, can store only 1 byte of data or only 1 byte of character. So you have to, so this is a restriction. You're placing a restriction so that your users or anyone else or any other programmer who comes next and modifies the code, he won't make any mistake by assigning different values, different arbitrary values, and it's going to cause a lot of problems. So we are restricting the amount of space that we can use inside the memory by using this data type, which is the character data type, and we're going to use 1 byte of character data type to store a variable with the name called ch. There are also other variables with the data type. You can create as many variables as you want, but there are certain types of there are certain data types. Another one is called the float. The float is actually a different one than the integer and character, and there is another one. Let me call this DEC1, and there is another one called double, and this will be called DEC2. Now you might be wondering, what are these float and double? The float and double are also data types, but they are used to store decimal values, which is you can store values like 23.0015, or you can store values like -100.013, or any type of decimal values. The problem with this integer data type is that it can only store, this container can only store whole numbers. If you try to store any decimal numbers, if you try to store any decimal numbers like 10.1 inside this container called num, then it's going to truncate that 0.1 from 10, which is, if you have a value that is 10.1, you will only, your compiler will first look at the data type, and the data type says that it is integer, which is you're placing a restriction that it must be a whole number. So your compiler will read the data type, then it's going to cut off that 0.1, and it's only going to store the 10 inside this container. It's not going to bother about anything that comes after the decimal point. It's not even going to touch the decimal point. But what if we have values like, what if we have suppose you're doing a scientific experiment, you're taking readings with your stopwatch, like a pendulum experiment, or there are experiments that include time in physics. So if you want to include that specified time inside a program, suppose you want to make a program so that you can input all the time in from your experiment, and that program will give you some type of result, like the average. You want to create a program that gives you the average time from 11 different experiments.